Rust doesn't usually handle errors using jumps in program flow like other languages with exceptions do. Instead, we have other methods for propagating and handling errors. I've written a simple function here that takes a JSON string, parses it, then extracts a name field from the JSON and returns it. But if there's no name field, or if there's an error trying to parse the input, then the program will crash and shut down. So we can run it immediately and see that we'll print out a name when we parse a valid bit of JSON. But instead, if we switch it to be not a valid piece of JSON, or to not have a name field, so we change this to age instead, and try and print that out, we'll get an error. So we see that the first statement ran, we printed out the name we found in the JSON, but the second piece of code that we tried to run caused the program to panic. So there was no name field, there was an age instead, the program shuts down. This is not what you want if you're trying to keep a program running for hours or days. So instead we need a way to handle errors that keeps the program running, but lets the code do the right thing. So let's see how Rust lets us do this. The first thing we need to be able to communicate errors is something which represents the errors we're seeing within our function. So we have, in both cases, just a string we want to communicate. So let's define a struct to wrap that. And we'll have a message field on our struct. And we'll derive debug to make it easier to look at this struct. And we also want to make this struct displayable, so we'll implement display. Which requires a function called format. And we implement that by doing write to the output formatter self.message as string. There we go. And then to make it a little bit nicer to construct this, let's just add a factory method. So we'll create an implementation with an attached message called of that takes a string and returns a name error. And we'll build name error with the message field set to message as a string. And that just saves us writing this piece of code every time we want to build one of these objects. Now we can define a new version of getName from JSON string that communicates with errors instead of panics when something goes wrong. So we'll copy the function. And instead of just returning a string, we'll return a result, which is a string when it succeeds, and a name error when it fails. And if we have a look at the definition of result, it's an enum, which is either OK or an error, and we'll see how to use that in a second. So you can see we've already got a result coming back from the deserialization library that we're using to parse our JSON. So let's give this a new name, which will be safe getName from JSON string. And then we can modify our logic here. So instead of returning the string, we return OK of the string. If we would have hit an error statement, we can now do error of name error, and we'll call our factory method to build a name error, and then same thing here, we'll return the error variant of the enum, and we'll create the name error from that string message. So this function behaves very similarly, but instead of crashing, it now returns a value. So we can update our piece of code that was throwing an exception to call safe getName from JSON string. So this is no longer a name. We could call it something like safe name result. And we want to look for an error because we know we've given it something that won't have a name. So we'll unwrap error. And then we can print that out. Print out its message. Let's have a look at that. This time the program shouldn't crash, it should handle the error properly. And it does. So it still prints the name, and then where there should have been an age, we're seeing no name field. So we should update our print message, but that is behaving much better than before. So this works well for communicating errors within your program, and it's a pattern you'll see used within standard library and many crates. But what if we don't really want to communicate the error? Maybe our program just needs the value if it's present and can continue just fine without it if it's missing. So there's another way to handle that rather than using a result. Create a new function called maybe_getName from JSON, and we'll use option instead of result. So that doesn't have an error, just a value, and it's either present or missing. So in this case we need to return sum of our string or a none if there's no result. So now we can't tell the difference between our two error cases, either the name field's missing or the JSON isn't valid, but when both situations are true, we can get back our value. So let's have a look at testing that. We'll take both of these and build another example for them with the option. So in the success case, we'll have a maybe name that comes from calling maybe_getName, and we'll print that out. We'll unwrap the option because we think it's going to be there. Let's update the message as well. Then we can try an error. So we'll take our previous error case that just has an age and no name, and we'll call it maybe name option by calling maybe get. And we don't want to unwrap that, we want to leave that in option form. And the only way we can really check this sensibly is just to compare it to the enum variant none. So maybe name option is none, and then we will print that out as name option was. That took a second to sort itself out there, but comparing two enums is fine, and printing out a boolean is fine. So let's jump over to the terminal and see how that code does. We'll cargo run that, and we see as we expect. So the first name comes out fine. There's a missing name field when we try to parse the document that has only an age, and then when we open up the maybe or the option, that has the value inside it, and when we try to look at a document that only has an age field again with option, we find that the variant we got back was none. So that's behaving as we expected. There's some more syntax that we can use to make some of this code a bit tidier, and there's also lots of methods on the result and option interface that let you write nice fluent code. But for now, this gives us a good starting point to start writing Rust code that can handle errors and missing data.